Hi students, now in the multiple choice questions in the chapter dual nature of radiation and matter, the third sum we are going to do. A particle of mass 3 into 10 power minus 6 gram has the same wavelength of an electron moving with a velocity of 6 into 10 power 6 meter per second. So the velocity of the particle is, so 4 options are given, we have to find the velocity of the particle. So what is given in the problem? I am making a list first of all. So mass of the particle is given. So that is taken as m1. So in gram they have given 3 into 10 power minus 6. I have converted into kilogram. So m1 is now equal to 3 into 10 power minus 9 kg. Then mass of the electron is not given in the sum. It is a standard value we must remember. So mass of the electron is how much? M2 is equal to 9.1 into 10 power minus 31 kilogram. Then the velocity of the particle only is asked now. So you call it as V1. V1 is equal to question mark. Then velocity of the electron is given in SI unit. That is V2 equal to 6 into 10 power 6 meter per second. So after listing this, what are the hints given here? So the particle has the same wavelength of the electron. It means the de Broglie wavelength of the particle is equal to the de Broglie wavelength of the electron. Okay students? So now you see here, lambda for the particle is equal to lambda for the electron. So de Broglie wavelength, we have derived an expression. So lambda is equal to h divided by mv. So Planck's constant. So this is h divided by m1 into v1 is equal to h divided by m2 into v2. It is given, is it not? The de Broglie wavelength of the particle is equal to the de Broglie wavelength of the electron. So h is Planck's constant, on both sides it gets cancelled. Therefore, shall we equate m1 v1 is equal to m2 v2? Okay. So I am going to equate here. So m1 into v1 is equal to m2 into v2. Now only one unknown quantity is v1, that we have to find out. I am going to substitute on both sides. So instead of m1, it is 3 into 10 to the power of minus 9, okay, into v1 we have to find out. So this is equal to m2 is what? Mass of the electron is 9.1 into 10 power minus 31 into velocity of the electron is given as how much? 6 into 10 to the power of 6. Easily cancelling numbers now. You see, I am going to readjust the terms, that's all. Therefore, what is v1 is equal to? Therefore, v1 must be equal to what? 9.1 into 10 power minus 31 multiplied by 6 into 10 to the power of 6 whole divided by 3 into 10 to the power of minus 9. So this 3 can be cancelled with the 6. 3 2s are 6. So I will write all the numbers first. So this is 9.1 into 2 into all the 10 powers I will write together so that easily you are going to understand now. So first 10 power is how much? 10 power minus 31 into here 10 power 6. So this is 10 power 6 into this 10 power minus 9 is coming up as 10 power plus 9. So this is how much? 10 power plus 9. Now 9.1 multiplied by 2, that is equal to how much? So this is 18.2. So this is 18.2 into, okay, 18.2 into, now 10 power minus 31. This is 10 power minus 31 into 10 power 9 plus 6 is 15. So this is equal to 18.2 into 10 to the power of 31 and that is minus 31 and plus 15 is how much? Minus 16. So this is equal to how much? Minus 16. Now this minus 16, if you adjust as 10 power minus 15 into 10 power minus 1, one decimal digit can be shifted. So front, so this is equal to 1.82 multiplied by 10 to the power of minus 15. Okay. Therefore, the velocity of the particle V1 is now equal to 1.82 into 10 power minus 15 meters per second. So 4 options are given. So which is the option? You see here A and D look alike. So quickly after looking at the number, you should not click A, because 10 power is how much? Minus 18. And here what is the 10 power? Is 10 power minus 15. So which answer should be correct? Is it A or D? Yes, it is option D. So this is option D. So this is how. So initially when you do, it will take some time. But similar problems, number of problems if you solve means, you will get an idea. You will get an idea how to synchronize the topics. Have you understood, students? So here what is the idea we are using? The de Broglie wavelength of the particle and the de Broglie wavelength of an electron we are equating. Okay, students, shall we go to the next one? Okay.